Welcome to today's webinar, Open Standards, the Importance of a Good Translation. My name is Ignacio Garcia, and I'm the product manager of the Protocol Translators family here in Intesis HMS. We're going to start with a brief introduction of the Intesis brand and the HMS family. HMS offers a wide range of products for industrial communication, ranging from embedded products, gateways, wireless, software, and cloud solutions, a strong combination of hardware and software. Our main brands are Anybus, E1, Intesis, XAT, Web Factory, Prosentech, and the latest one, Oasis. We all have a strong position in the market of industrial communication and protocol translation in 4 vertical markets: manufacturing, energy and infrastructure, transportation and logistics, and building and HVAC, where Intesis have more than 20 years experience helping system integrators in their projects all around the world. And that is what we would like to share with you today: the experience of thousands of projects with an heterogeneous palette of open standards for all sorts of applications. That could sound very ambitious for a 20 minutes presentation, so we are just going to focus on the basics and some tips and tricks that will show you the importance of a good protocol translation in your KNX automation projects. In today's webinar, we will cover 4 main topics: the basics of open standards. We will look at the global industry and nowadays picture of the most used open standards. And we will take some time to explain the importance of a good translation by giving you a set of rules for a KNX integration, and also a short introduction of solutions provided by Intesis. And we are going to begin with the basic definition of an open standard. So, what makes a standard open? Well, it's typically an international set of rules to design and implement features that we manufacturers can use in order to implement or launch to the market products following those design rules. They typically have a certification process where every manufacturer can address to and make sure that the products that we launch to the market are according to this international standard. It's typically an international community. Meaning that it's easy to use and easy to access to by installers or system integrators all over the world. These open standards are typically offering a scalable product, scalable systems with to create safe and secure systems as well. And it's also a future-proof technology. These associations behind these global standards, they are developing new features, new ways of, new rules for design and implementation of these open standards in the world. And that's what we can see here. A nowadays picture of the most used standards, what we call the global building automation industry. And as we can see here, most of the used ones we already know. We know KNX, of course, but BACnet is also there, Modbus, ASCII, Alongworks, also more specific ones for specific applications within the building, like DALI for lighting control, or MBUS for energy metering, or even now OCPP for integration of electric vehicles charging point. And of course, wireless technologies like Notion, Z-Wave, or ZigBee. And since all these standards are part of the world, that means that we and you, system integrators, can access to these technologies and these products. So we need to learn how to work together. We need to learn how to communicate with each other properly. So why a good translation is important? Well, not only because you might be missing something, as you can see here in the comic, but also because a bad translation, it can generate a lot of pains in your day-to-day job and projects. The lack of knowledge in one protocol, the missing features and data types or the configuration options, the data point capacity, it can generate to reduce the space in the cabinets by adding unnecessary products or unnecessary devices. And even when you are going to trying to communicate with a different standard than the one that you are using, perhaps you don't reach these devices because they are wrongly wired. And when you start with the configuration or the integration of these devices, these complex configuration tools can generate longer commissioning times, therefore project delays. And this is something that certainly as a system integrator, you would not like to have. So hence, this is the importance of a good translation. We need to prepare you to have a good translation from and to KNX. And that is why we have created a basic checklist that will allow you to, before you start the project, even in the design phase, you can go through it and check the physical connection, the system architecture of the different protocols you want to use or integrate. How can you connect, or what should you keep in mind when defining the amount of data points and devices, and the configuration tools that should be flexible enough to allow you the right setup. And of course, security for your systems. So let's start with the physical connections. And when physically connecting two or more devices, more different protocols, we need to look at the way these networks are connected. In physics, not everything is allowed. Wiring, cables, voltages, amps need to be calculated upfront to enable safety and proper shape for communication. The same goes for wireless communication. Restrictions on the radio frequency usage, potential blocking points in the building, they all require a proper study and verification before we can install the devices. And each open standard defines a set of rules for the physical communication layer. This layer describes the way each protocol should connect to each devices. And here we can see a few examples on the different protocols, open standards that we have talked before. For example, in KNX, we can use twisted pair or IP or other methods. For Modbus and BACnet, we can use IP communication or serial communication over RS485 or RS232. In DALI, we use two poles cables, and it requires to have an independent power supply for DALI communication in the bus. Something similar with M-bus, where we need also as well a level converter in the network. For long works, we can use twisted pair with the restrictions that they have, and also for ZigBee, Z-Wave, Bluetooth, wireless technologies, which typically air is the transmission method. And as we can see in this example, a protocol translator that enables communication between KNX twisted pair and Modbus RTU is the responsibility of us, the manufacturers, to describe properly in our documentation how you should connect each communication bus with the particularities of each protocol supported. Another important check in our list will be the system architecture. This should be a layout of all the different devices installed in your system and how should they react or interact with each other. When combining products in a KNX installation, the order versus action logic is intrinsic to the device. That's what we call distributed processing or distributed intelligence, meaning that each device can receive and send orders to the rest of the network. But that is not the same for every open protocol. In some other protocols like BACnet or Modbus, we can find a more strict way of communication. following a master, slave, or client-server methodology. So what happens when the protocols that we use for the field devices is not the same as the one that we use for the controllers or the controllers network? Well, we need to use a protocol translator to enable the communication. And in this case, here's the tip for you. The master-slave client-server combination changes a little bit. And now on the controller side, the master remains the same, but the slave becomes the gateway or the protocol translator. And on the field devices side, the slaves remain the same, but the master needs to be the protocol translator or the gateway. Like we can see here in the example of the Modbus integration into KNX. The KNX side, the KNX system remains the same. We just add a new KNX device, in this case, the gateway. And on the Modbus side, the Modbus slaves are still the same, but we need to introduce the Modbus master in the network, which in this case, this role will be taken by the protocol translator. Next point in your checklist should be the amount of data points required. A data point is a variable, a data point or a variable is a virtual command that enables control and or monitoring of a certain feature of each device. Device manufacturers should document how these devices, how these variables work and list them in their documentation. So you, the system integrators, can decide which one suits better for your application. Like in this example of a fan coil controller, where we can find a long list of variables with their definition. Our tip here will be to calculate upfront how many variables would you require to integrate from or to your KNX project. In this case, this fan coil controller has 154 variables. Calculating how many do you actually need will help you dimension your project properly. Something similar happens with the physical devices that you would like to integrate in your KNX project. Sometimes we can get confused when calculating how many actual devices can we connect to a certain protocol. And depending on the protocol, we talk about devices, addresses, nodes, and that can be confusing. For example, in a DALI2 network, we know that we need that we need to have an application controller with a DALI power supply. Now, the standard says that we can connect up to 64 DALI addresses for ballast and drivers, and 64 DALI addresses for sensors or input devices. But we need to look at the physical connection as well. So the DALI power supply, it is typically rated between with a maximum of 250 milliamps. That's the capacity of the gateway of the system, with a recommended capacity of 230 milliamps. Now, if we look at the standard, it says that each DALI2 driver should not use more than 2 milliamps. But when it comes to input devices, the standard doesn't really say or state how many milliamps should consume each of these devices. So it's up to the manufacturer's choice to design a product with a certain amount of milliamps. So how many DALI2 devices can I connect to my DALI network? 64, 128? Well, we will see that in this example. In our KNX DALI gateway, we state that we can connect up to 64 DALI2 drivers and up to 16 DALI2 sensors. But this is considering that each sensor does not consume more than 5 milliamps. This capacity is subject to change when the sensor model have a different current ratings. So we provide these numbers as an example. It is up to you to calculate the right one. Now, the wiring is correct. The system architecture is perfect and the size of the project is optimal. We need to make the devices talk. But before they can understand each other, we need to set the rules for a proper, educated communication for both parts of the installation. Every open standard communicates using different packages, and we call them data points in KNX, registers in Modbus, objects in BACnet, each of them with a different set of rules that defines what contains and how to understand it. A flexible configuration tool, then, shall offer simple and unadvanced settings to adapt each network to each other. Many protocol translators offer this tool directly integrated in the ETS database, or dedicated KNX plugins, for example, or the use of independent configuration tools like Intesis maps. Coming back to our previous example, we will be able to find in the fine call controller documentation all the requirements for their Modbus communication, the baud rate, the data types, the format, length, byte order. So how can we make sure that we are translating these Modbus registers into the right KNX data point? Well, having a flexible configuration tool that supports all these variables will help us program the master, or the gateway in this case, with the proper settings on the Modbus side. But it's also very important to be able to configure how we need to translate these registers into KNX group objects, adapting the register values to the proper data point type, or even offering advanced features like operations to make sure that we get the best out of our translation. Our last checkbox for a good translation is one of the most important topics of our time: data protection and security. Industrial communications are moving beyond the four walls of the building. The value proposition of internet connectivity is too strong, and having devices that could potentially expose our data could diminish its value. That is why many open standards are offering to manufacturers a way to supply secure connections. And there are specific parts of the standards that define the rules for this, like KNX Secure or BACnet Secure. But it's also the responsibility of each manufacturer to ensure secure communication, basically to the access point of each network, like in this case would be gateways or routers. Our example here will be our KNX to BACnet gateway, and the way we can limit the access to the configuration tool maps and the existing programming in it. Thanks to password-protected access and discovery restrictions over TCP or UDP, we can make sure your configuration is protected. As we think in HMS, if you want to stay competitive in an international environment, you need to comply with the security demands of end users. Therefore, we will continue expanding our security mechanisms all over our protocol translators family. Now, you have checked all your boxes for a good translation. You will surely start enjoying the benefits of it. Thanks to these good practices, you will manage to optimize your resources, shortening your integration time with less technical issues, and providing a reliable system to your customers. In the end, the importance of a good translation will mean to gain confidence in the integration of different open standards, to expand your portfolio, and essentially bring more business. And for a good translation, trust in Intesis protocol translators. Our portfolio covers all these protocols and more to come in the future to help you out there in your protocol translations. That's all for today. Thank you for your presence here today, and now it's turn for the Q&A session.